In this video, we're going to be introducing the last three types of chemical reactions, determining their general formulas, and showing how we can use their general formulas to determine when each type of chemical reaction has occurred, starting with the first example of a new type of chemical reaction, the double replacement or double displacement chemical reaction. Now, for those that remember single displacement or single replacement reactions from the previous video, mechanically, double replacement reactions are quite similar, only instead of having an ionic compound and a single element that replaces one of the elements in the compound, we actually have two ionic compounds, in this case, silver nitrate and sodium chromate, although in our general formula, we can simply designate these as AB and CD as our reactants. Now, in a single displacement reaction, the singular element replaces either the metal or the non-metal, or rather the cation, the positively charged ion, or the anion, the negatively charged ion, depending on what the element is. But in a double displacement reaction, the cations of each of our ionic compounds switch places like this. Now, if you want to do this with the anions instead, you'll end up with literally the same thing, so it doesn't really matter which we frame it from. What we can say is the metal on or cation on one ionic compound switches with the cation on the other ionic compound, resulting in the opposite compounds as products. So here we can see that silver displaces sodium, and now we're going to have silver and chromate paired with each other like this, and likewise sodium displaces silver, so now we will have sodium and nitrate paired together like this, resulting in the cations and anions of the two ionic compounds switching as we see here. Now, in order to complete this chemical reaction, we need to check our periodic table to make sure that the charges of all of our product compounds are sufficiently balanced. So if we take a look at silver, it has a charge of +1. Sodium, we know as an alkali metal, will have a charge of +1. And then our two polyatomic ions, chromate has a charge of -2, and nitrate has a charge of -1. So if we just double check our charges, we can see that silver and chromate's charges do not balance out, but we can fix this by adding 2 silver, because +1 times 2 is +2, and +2 minus the -2 charge of chromate, +2 minus 2 is 0. However, with sodium and nitrate, we can see that their charges are canceling out directly, because +1 minus 1 is 0, and so we have our double displacement reaction. So if we convert this into a general formula, our cations A and C can switch places with each other, and silver chromate is an example of our first product, AD, now paired with each other, and sodium nitrate is an example of our second product, which we can call CB. Now, for those that know how to balance chemical reactions, we're going to leave that out in this video for the sake of time. If you want a tutorial on balancing chemical reactions, that is the topic of the video that is next in this series. Now, a subset of double displacement or double replacement reactions are what we call neutralization reactions, and we say that neutralizations are a subset of double replacement reactions because, as we'll see, they are actually a specific example of double replacement reactions, only with very, very specific reactants. So here we can see our first compound is not exactly an ionic compound. This is actually an acid. We can tell because hydrogen is the first element in the compound, and hydrogen is paired with some sort of anion, that being phosphate in this case. So in our general formula, we can designate this as HA, A for acid obviously, and H being the hydrogen. Now the opposite of an acid is what we call a base, and we can identify calcium hydroxide as a base because of the presence of OH minus. So we can designate this in our general formula as BOH. Now, if we remember that neutralization reactions are actually examples of double displacement reactions, that means we can predict what the products are going to be, even if we don't really know what a neutralization is. Because if we take the two elements that would form positive ions, because hydrogen isn't a metal, but it still loses one electron easily. So if we take the hydrogen from our acid and exchange it with the metal in the base, we can determine what our products are going to be. So our first product compound is going to be Ba, the metal from the base, switching places with hydrogen in order to pair with the anion, the negative ion from the acid. So this would be calcium phosphate. And again, we'll need to check the charge to get the correct chemical formula, but then we have the hydrogen displacing the metal from the base, meaning that the hydrogen is now going to pair with the hydroxide. And instead of writing HOH like this, we can simply write it as H2O, which of course is water, and we can just write out the chemical formula H2O like this. And to finish our product compound here, we can double check the charges for calcium and phosphate. Calcium has a charge of +2, and phosphate has a charge of -3. So we see that they don't exactly match, but we can find the lowest common multiple between 2 and 3 is 6. +2 times 3 calcium is a total positive charge of +6, and -3 times 2 phosphate is a total charge of -6. +6 minus 6 is a total charge of 0. So here we can see that even though neutralizations are specifically a reaction between an acid containing hydrogen and a base containing hydroxide, because mechanically they function the same as a double displacement or double replacement reaction, we can see that we can predict how a neutralization will work exactly the same way as a double displacement reaction. Our final category of chemical reaction are what we call combustion reactions, and there are two varieties of them. The first of which is what we call a complete combustion reaction. Now, if you'll observe the fires in both of the pictures here, that's exactly what a combustion reaction is, in that we start with some sort of carbon and hydrogen containing reactant, and in future grades you'll recognize that this is an example of what we call an organic compound, meaning a compound where carbon and hydrogen are the primary elements in their structure. Now, anyone who has any expertise about fire knows that you need oxygen gas in order to start a fire. Let me just correct the writing there. Oxygen gas. Since we can't start a fire without oxygen, this is automatically going to be the second reactant. And when a combustion reaction occurs with enough oxygen gas, we get a complete burning of our organic compound, resulting into products that we normally associate with fire. The first of which is carbon dioxide gas, which again is the gas that we produce when we exhale. And of course there is water vapor, and anyone who has observed steam being released from a fire, what you are observing is the water from the organic compound reacting with oxygen being released as a gas like so. Now again, we're leaving the balancing to the next video because once again, balancing combustion reactions is quite tricky. If for those looking for strategies about balancing combustion reactions, you can take a look in the next video. However, there is a variety of combustion reactions which are what we call incomplete combustion reactions, and from the name you might be able to figure out exactly what the deal with incomplete combustion reactions are, because complete combustion requires enough oxygen gas in order to burn our organic compound completely. However, if we take our organic compound and react it with an amount of oxygen gas that isn't enough, so let's just write under or above oxygen, not enough. If we try burning our organic compound in an oxygen poor environment, for example, if you try smothering a fire and preventing oxygen from getting in and burning our organic substance, there are a couple of additional products that result. We get carbon dioxide and water vapor just as a normal complete combustion reaction does, but many people associate poor burning with this black smoke here, which is actually elemental carbon that is produced because there isn't enough oxygen to react with the carbon in the organic compound. And we also get a very, very deadly gas called carbon monoxide here, which is actually a very deadly poison that can actually cause asphyxiation, which is death because of a lack of oxygen if you breathe enough of it in. This concludes our video series on identifying types of chemical reactions. So in order to test your knowledge of the now 6 different types of chemical reactions, you can take a look at the practice problems below and use the general formulas that we've discerned over the last couple of videos to identify what the type of chemical reaction is. And in the next video, we will focus on learning how to balance the reactants and products of a chemical reaction, in which case you can come back and complete the balancing of each of the practice problems below.